Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is differential equations. In this video, we will be giving an introduction on this topic. So what is an equation? Generally an equation can be written like this. Say y equal to 3x plus 4. So this is an independent variable. This is a dependent variable. Why? Because y depends upon x. So this is an ordinary equation, not a differential equation. In the differential equation, we get the terms such as dy by dx. So for example, 2x dy by dx plus y equal to 0. This is an ordinary differential equation. Ordinary differential equation. What is the difference between ordinary equation and ordinary differential equation? Here we have the term dy by dx. So this is very important. So ordinary differential equation is different from ordinary equation because there are derivative terms in that. Similarly, another equation we can write higher order terms also. Say 3d square y by dx square plus say dy by dx the whole square equal to 0. This is also an ordinary differential equation. 3dx square y by dx square plus dy by dx the whole square equal to 0 is also an ordinary differential equation. You may be thinking, okay, this is a differential equation. Why we call this as ordinary? Are there any special type of differential equation? Yes, there are special type of differential equation, but they are not in your syllabus, and those are called as, I will give the name, partial differential equation, PDE. When you get independent variable as a function of only one independent variable, it is ordinary. If dependent variable is a function of more than one independent variable, then it is called a partial differential equation. You need not worry about that. In your syllabus only ordinary differential equation is there. So you will get only terms such as dy by dx. What is order of a differential equation? Order of a differential equation is defined as the order of the highest order derivative of the dependent variable with respect to the independent variable. So we have to see the derivative term which is of highest order. So in this the derivative term is dy by dx. So it has only first derivative. So this is a first order differential equation. Now in this equation we see the highest derivative term is this d square y by dy, d square y by dx square. Second derivative term is there. So it is a second order derivative. Please note that if I put it here like 5, then this is not a fifth order differential equation. This is still a second order differential equation only. Why? Because we have to see the derivative, highest derivative term, which is this. Similarly, for a nth order differential equation, this will be the nth order differential equation because we are derivating y with respect to x nth time. So this is very important. This is called the order of the differential equation. Now we'll come to the degree of the differential equation. Order is the highest derivative we got. So the order of this differential equation is clearly 1. Sorry, order is 3. Order is 3 because 3 times we are finding the derivative of y with respect to x. Order is 3. But the degree of a differential equation is the polynomial equation in derivative. We mean the highest power of the highest order. So the highest order is this, not this. So if the highest order is this, its power, highest power is 1. So its degree is 1. Suppose this differential equation was written like this, power 2, then its degree will be 2, but order will remain same as 3. Now let us try to find the solution of a differential equation. What do you mean by, let us take a simple differential equation, say d square y by dx square plus y equal to 0. So what is the solution of a differential equation? Solution means we have to find y for some function like this, x or y, so that if we find derivative and the second derivative and put it in this equation, then it becomes 0. So our aim is to find a function y equal to 5. So how do we find for this equation? Let us take one example. Let y equal to a sine x plus b. So this is a solution of this. How do we know this is a solution? We will find the first derivative, y dash equal to a cos x plus b, y double dash equal to minus a sine x plus b. Now we'll put it in this, y double dash is minus a sine x plus b. What is y? Y is plus a sine x plus b. This is indeed 0. So this is satisfied. So y equal to this is a solution of this differential equation. Y equal to a sine x plus b is a solution of this differential equation. So this is called as the general solution. This is called a general solution. Why it is called a general solution? Because we haven't defined a and b can be anything. For example, if we want say y equal to 3 sine x plus say pi by 6, we have defined now a and b. A as 3 and b as pi by 6. So this is called a particular solution of this differential equation. So we found the general solution of a differential equation and we also find the particular solution. Now you may be wondering how we got this, how we got the general solution. Is there a way to find that? Yes. In your future videos in this particular topic, we'll be showing how to get the general solution and the particular solution. We'll be discussing on that. Now let us try to find the solution of a differential equation using separation of variables. So let us take one example. For example, dy by dx equal to x plus 1 by 2 minus y naught equal to 2. Now we want to solve this differential equations. How do we do it? We cross multiply. Take all the y terms here and take all the x terms here. So we are separating x and y. That is why it is called separation of variables. So we can write this 2 minus y dy equal to x plus 1 dx. How do we solve this? We put integration both sides. So this will be 2y minus y square by 2. This will be equal to x square by 2 plus x plus some constant, say c1. We multiply this throughout by 2. So this will be 4y minus y square equal to x square plus 2x plus 2c1. So we can simplify by taking all the terms here. So x square plus y square plus 2x minus 4y plus 2c1, we can write it as another constant c. This is equal to 0. So this is the differential equation, or this is the equation whose solution is this. So we have found the solution of this particular differential equation as this. Now we come to another important topic, like what is homogeneous differential equation. So let us first try to understand what is a homogeneous function. So homogeneous function, let us take any function f of x, y. If we can write this function as f of lambda x, lambda y equal to lambda n f of x y, then f of x y is a homogeneous function of degree n, So it has to be written like this. We'll take one example. Say for example, if we take f of xy equal to say y square plus 2xy, then we can write f of lambda x comma lambda y. Wherever xy is there, we'll put lambda there. So lambda y square plus 2 lambda x into lambda y. So this can be written as lambda square y square plus 2xy. So we have written this function f of xy this in this form. So this f of xy here, this function is a homogeneous function of degree 2. So similarly we can write other functions also. For example, if we can write function f of xy equal to x power n g y by x, or equal to, or put it as y power n some function h x by phi, then f of xy is again a homogeneous function of degree n. So this is the definition of homogeneous function. But what is homogeneous differential equation? If we can write a differential equation dy by dx equal to f of xy, and if f of xy has degree 0, then it is called a homogeneous differential equation. I repeat again, if we can write a differential equation dy by dx equal to a function f of xy, and if f of xy has degree 0, then it is called a homogeneous differential equation. We'll come to linear differential equation. So what is a linear differential equation? Let us write the equation dy by dx plus py equal to q, where p and q are some constants. Then this is a linear differential equation. Why it is so important? We can easily find the solution of linear differential equation by first writing the integrating factor, written as e power p dx. So we multiply all the three parts here by the integrating factor. So we'll get this as e power p dx dy by dx plus p e power p dx y equal to q e power p dx. But what is this? But what is this term? This can be easily written as d by dx y e power p dx equal to q into e power p dx. Now if we take integration both side, this term will get cancelled. So this will be y e p dx equal to integral q e power p dx plus c. We can take this term also here and get a y as a solution of x. So we know how to find the solution of a linear differential equation if it is in the form dy by dx plus py equal to q, where p and q are constants. Then first we find the integrating factor. Then we can write the solution as y into integrating factor equal to integral q into integrating factor dx also will be here, plus constant of the integration. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.